Very excited about this particular panel, which really gets to the heart and the theme of our conference, which we hope you're having a good time. You went to the reception? Wonderful. Thank you very much. It's all home-cooked meals from home. So it's great to see you here. And as I said yesterday, what we wanted to do in this conference is deal with a big challenge, and nothing is bigger than the existential crisis that we face today and how we manage to live on this planet sustainably. How are we able to go and live in a planet where the population is going to achieve 9.3 billion by 2050, but where we're already vastly overutilizing the resources that our planet provides for us? If the slides started, please. Thank you. And as you can see from up here, the folks I'll introduce in a little bit, this is really a stellar panel of experts that are going to share with you their views and how we can actually work to deal with this challenge. So again, how do we deal with this challenge of living on the planet sustainably? And in fact, as we know, environmentalism and health have often operated for far too long as two separate silos. But if you think about it, they're of course intimately entwined. You cannot separate the health of our planet and the health of people. And if you wanted to go a little step further, if we were to define global health in the 21st century, could we not argue that global health is the well-being of people and the planet? The sustainability challenge is water. Only 3.5% of the Earth's water is fresh water. But if you take a look at the utilization of water today, we're vastly overutilizing it. Pollution is a massive problem, one of the biggest and neglected killers in the world. And in fact, as we can talk about maybe a little bit later, we have Dr. Phil Landrigan here, who's right there. Dr. Landrigan is co-chairing a Lancet Commission on pollution, health, and development that's going to release its findings very, very soon. The sixth extinction, often ignored, but it's interesting, the benefits of biodiversity in public health is actually remarkable. And if you look at the Center for Biological Diversity in Montreal, they've done incredible work showing that biodiversity losses have a huge impact on public health. Conversely, if we protect ecosystems, if we're able to change this problem, where we have literally lost 50%, imagine, 50% of the world's wildlife has been lost in the last 40 years alone. What are we going to see on this planet in the next 10, 15, 20 years? Climate change, perhaps the most, in this larger existential crisis, a huge, huge existential crisis that we're facing, and in some quarters even are not believed, as we know. Our job as scientists is how are we going to change this so we can deal with this challenge to all of us, and of course land degradation. And we have infectious diseases, old and new, and you're going to hear from some experts today on some of those infectious disease challenges that we know are going to happen in the future. The social determinants of health and the sustainable development goals, how are we going to deal with those? Infectious diseases, as I mentioned before, and the non-communicable diseases, ignored, underrepresented in the investments that we make, and yet are killing more people than infectious diseases and will do so even more, hitting low-income countries harder than high-income countries. And food security. How are we going to feed a population on this planet of 9.3 billion when we're already overutilizing the ecosystems of today? So CUGH, we're working with groups like the Planetary Health Alliance and others, the One Health Commission, to be able to aggregate good practices, identify training modules, train the trainers, and engage in advocacy to be able to protect the investments in those agencies that perhaps get ignored, but are vital to global health and vital to the well-being of people, including not only the National Institutes of Health and the Fogarty Institute, which we've spoken about, but the Environmental Protection Agency, the Centers for Disease Control, and the National Oceanographic and Atmospheric Administration. These are ignored, and yet they are pillars that actually gird the ability of not only to keep Americans safer, but keep the world safer, more prosperous, and secure. Lastly, I just want to talk about something that I think is really ignored in global health, and hopefully will be a reoccurring theme. All of us have our own interests in what we want to do. We might be interested in drugs and vaccines and devices, training human resources. But none of this happens without strong public institutions and good governance. if you were to take a look and look at the countries that are poorest in the world, the ones that are perpetually suffering indignities and have some of the worst health outcomes in the world, if you look at them, they all have one thing in common. They have weak public institutions and poor governance that breed what I call the 3 C's: corruption, conflict, and a lack of capacity. So as we have our own interests in developing new drugs and devices and training people, let's not forget that it's vitally important when we work with our colleagues sensitively as to how we can build and create a sustainable and effective public institutions and good governance across not only ministries of health, but finance and justice and public works and the environment. These are critical pillars for global health. So I'll stop there and just announce our stellar group of speakers that we have today. We have today Dr. Richard Horton, great friend of CUGH, champion of planetary health, leader with the Planetary Health Alliance and the Rockefeller Foundation in moving this forward substantially. And we're very proud to say, we hope you will visit the Lancet, I'm doing this, Richard? He didn't pay me to do this, but the Lancet Commission's first planetary health journal has just been released. Copies of it are downstairs in the Lancet's booth, along with many other of its stellar journals, including the Lancet Global Health, and also a copy of the Lancet Commission on Planetary Health. That is all down there, so please pick up a copy. We also have Dr. Julie Turton. Dr. Turton is from the National Oceanographic and Atmospheric Administration. She is the One Health Integrated Climate Change Specialist. The next is Dr. Montier Ponsiri. Dr. Ponsiri is the Senior Science Policy Advisor for the Planetary Health Alliance. And Dr. Andrew McCabe, another good friend of CUGH, is the Executive Director of the American Association of Veterinary Medical Colleges. You also have in this audience Dr. Pat Conrad and many others, Dr. John Patz, who's there, who are experts in this field. So make sure you speak to them also if you have a chance to do so. So without further ado, I am delighted and honored to introduce Dr. Richard Horton.
Thanks so much, Keith. 8:15 Saturday morning, inhuman. So thank you very much indeed for getting up and coming to this session. Last week, a few of us, Phil Landrigan and maybe others actually, I don't know who's in the audience, were in Rome. We were trying to heal, in our tiny, tiny little way, 400 years of schism between Galileo, representing the scientific community, and the Catholic Church, trying to build a new coalition of interest between the faith communities and the global health communities. And it was a poignant moment because we were meeting in a stunning building whose back door overlooked the Roman Forum. So as we walked from our hotel to this magnificent, it was effectively a chapel where we were meeting. As you walked out of the hotel, on the left-hand side, you saw the Colosseum down one part of the road, and then you had the Roman Forum to your right. And it was poignant because we were talking about the future of humanity. That was the title, rather overambitiously, of the conference. And there we were, in the ruins of one civilization, contemplating the future of another civilization, our own. That's planetary health. The trick for every civilization is to try and figure out and understand, to get to grips with, the predicaments, the lethal existential predicaments that civilization faces. And sometimes civilizations have succeeded, but as you know from your visits to museums, the ruins around us in the world, civilizations always fail. And there's no reason why in 200 or 300 years' time, your children, my children, will be going to a museum looking at the wonders of our civilization and marveling at how stupid we were. That's planetary health. It's the connection between biodiversity and politics, between economics and climate change. It's purely interdisciplinary. It hasn't existed before. Let me give you a concrete case because it can get a little bit abstract and ethereal, and I don't want it to be. I want it to be very real, grounded in the lives of people around us. I don't know how many of you read the paper from the Brookings Institution that came out just actually a week ago, just over a week ago, by Anne Case and Angus Deaton. And this paper looked at the fate of white non-Hispanic Americans in the United States. White non-Hispanic Americans in the United States have seen a rise in their all-cause mortality from drug overdoses, an opioid epidemic, from suicide, and from alcohol-related deaths. Angus Deaton and Anne Case call these the deaths of despair. And it's astonishing, if you look back, 1999, mortality among white non-Hispanic Americans in the middle-aged group of life was 30% lower than African Americans. By 2015, it had flipped. It was 30% higher than African Americans. Now, what's the reason for this generational, dramatic increase in mortality among this part of the population? A lot of people have put it down to income. Absolutely not, argues Angus Deaton, Nobel laureate in economics. The answer for this crisis in this particular stratum of American society is a civilizational collapse for that community. A collapse of marriage and family, a collapse in labor markets and employment opportunities, a collapse in education, in health systems, a collapse in faith communities, which used to provide the cultural capital binding those communities together. Almost every dimension of those communities that built solidarity, hope, and prospect has been destroyed. That's planetary health. The cumulative disadvantage affecting our communities. Planetary health can't exist without public health and global health. Public health is about issues related to health promotion, health protection, health services. Global health about the transnational forces shaping our future lives. And planetary health about a broader set of forces looking at not just the community, but literally all the forces shaping a particular civilization. Of course, as we've heard already in this conference, the era that we're in, the Anthropocene, is absolutely crucial for framing the idea of planetary health. And we're coming up to a very important moment in the annual calendar. And it's interesting to reflect on it. 1962, Rachel Carson's Silent Spring, still a book that's very much worth reading. And by 1970, 20 million people, incredible, 20 million people around the world walked on April the 22nd, the world's first Earth Day. And we're coming up, April the 22nd, to another Earth Day. And what did those 20 million people do in 1970? They created a new movement, an environmental movement that again brought environmentalism center to the political stage. Now, do we have a Rachel Carson, A Silent Spring for our time? Well, maybe we do. This is the book, Tony McMichael, Climate Change and the Health of Nations, Famines, Fevers, and the Fate of Populations. It's just come out. Many of you will have heard of him, some of you won't. Tony McMichael, an Australian epidemiologist who very sadly died in 2014, but thankfully just finished his manuscript before he passed away, tragically, unexpectedly. And his colleagues curated his text, and his book is now out. And in this book, it is in a way a seminal text for planetary health, because he writes here about the mega problem of disordered human ecology, and he talks about the fate of civilizations. Climate change is not about carbon dioxide. Maybe Scott Pruitt was right in that one respect, because what climate change is about, it's about the fate of civilizations. And it's understanding the scale of the change in the way we live our lives Do we really understand? We have one generation, 20 years, to get this right. That's it. If we miss this opportunity over the next 20 years, we're in trouble. I mean, seriously bad trouble. Irreversibly bad trouble. If we're going to meet the Paris Climate Agreement, taking action to limit global warming to 1.5 to 2 degrees Celsius by the end of the century, that means we've got to have a peak in our carbon emissions by 2020. 2020, just 3 years away. And then they've got to start turning down. That means we've got to eliminate fossil fuel subsidies now. It means by 2030, we need to have eliminated coal, despite President Trump's signature and executive order in the White House. We need to have actively sought to eliminate coal from our energy mix. By 2040, we need to have actively sought to eliminate oil from our energy mix, replacing these by renewables. And we need to create the markets to do so. That means that by 2050, we will be living in a carbon neutral world. 0 carbon emissions. Indeed, we'll need to have gone further than that. We need to have implemented technologies for carbon capture. Atmospheric carbon dioxide is over 400 parts per million today, consistently over 400 parts per million. We need to get it down by 2050 to 380. We need to be bending that curve. All the great things we're going to talk about in the next session. I'm so pleased César has won the Gairdner Award. It's been my privilege to publish some of César's work in The Lancet, and he's a richly well-deserved winner of the Gairdner Prize. But all of his work will be complete waste of time if we don't fix this. It's no good saving children's lives in the short term if we kill our planet in not even the long term, the medium term. So we have these 20 years. And there are some big unanswered questions, and this is why it's a civilizational challenge. Our societies in the West are based upon 2 ideas, liberalism and democracy, the supremacy of liberty. That's what the Declaration of Independence in this country talks about. The institutionalization of liberty as the central defining theme of the way we live our lives. That is fantastic, and it ushers in a concern for human rights, and we all buy into that. But the trade-off that we did when we entrenched liberalism and democracy as the foundations for Western society, the trade-off was that we put the notion of a collective life to one side. And now what we have to do is to navigate this very difficult path in retaining the foundations of Western society, liberalism and democracy, while bringing back into our political discourse the notion of a collective life, the interdependence that we have one with another, the lives we share together as a collective humanity. And you know, we don't know if we can do that. That's the great test of our civilization. A second great challenge is that it's not just about the environment. It's also about other toxic issues that shape our response to the environment. And the most important one of those is inequality. Just yesterday, we published a series of 5 papers on inequality in the United States. Inequality in the United States is going to be that toxic issue that accelerates the impact of environmental change. Because for those of us, and you are part of them, you and I are part of the problem, we are part of that group that is not going to feel the effects of climate, environmental degradation, biodiversity loss. There's a very large group of people, 2, maybe 3 billion people, who are going to feel that loss. People who are living in lower middle income countries. They are going to feel the effects of that biodiversity and climate loss. But we won't. And that inequality that shapes their futures and shapes our futures is so divisive because it feels like there's no incentive for us to act on their behalf. And that's where this notion of interdependence and the collective life becomes so important. We have to make inequality our number one political issue, along with addressing these environmental challenges. And that brings us back to the whole question of democracy. We say democracy is the best political system out of many bad political systems, but is it really capable of addressing these challenges? Again, we don't know the answer to that. That's an empirical question we're going to have to see. Democracy, compared with autocracy, has many advantages. When I go to China, it's impossible for me to go to Tiananmen Square and put out a banner and criticize the government. I can do that outside the White House here. So I can create demand here in a way that I couldn't in an autocracy. But what I can't do here is guarantee a response. Whereas in China, once the government is convinced, they act and nobody's going to stop them. So democracy is good at enabling freedom of expression and creation of demand. It's very poor at responding. Also, in democracy, our institutions are fragmented. We pride ourselves on the checks and balances that we've introduced into our democracies. But those checks and balances are also our greatest weakness, because again, they prevent us from acting when we need to act. And we're seeing that, I'm afraid, in our political structures today. So, planetary health is dealing with the most existential threats that face our civilization. There are many open questions that we don't have the answers to at the moment to know whether we're going to be able to navigate the next 20 years successfully. We do know what we need to do to navigate those years. We have no idea whether we have the capacity as a species. But what we do know is that we have to change the way we look at ourselves, we have to change the way we work with one another, and we have to create unprecedented collaborations, coalitions, and communities of common values and common interests to shape the future trajectory of our great global civilization. Thank you.
Thank you for that amazing introduction to our entire, the issue for this whole panel. I couldn't agree more. I was actually thinking about Rachel Carson's Silent Spring on the way in this morning and about how we are at a moment in time where we do have to behave and conduct ourselves differently as a community. And it leads me to the first thing I wanted to start with is a big thank you for being here. I am actually genuinely honored to be here representing the climate and environmental side of this equation. And so often, you know, we will have meetings on the climate side about impacts on drought and health and whatever, and there's one or two health folks in the audience, and the reverse is also true. So in terms of new coalitions and new partnerships, I thank you very much for having me here. And I know many of you have been working at this interface for a long time, but I couldn't agree more that it's time for a real fundamental shift in how we work and how we proceed the next decade or two. So, I'm Julie Turton. I'm from the National Oceanic and Atmospheric Administration, and my job is, my first job is to figure out how to work this thing. Yep. Okay. So, I am in charge of the health activities across NOAA, which means basically we have a lot of pieces of our agency that work with or contribute to or have impacts and knowledge about health effects, planetary health, animal health, human health. And my job is to coordinate those activities across the agency with other health interests and health agencies of the US government. The second part of my title is, though, Integrated Climate and Weather Extremes Research. So I'm going to talk a little bit about the combination of all of those things. One of the things I'll start with is just a bit about how the Earth systems are changing. And Keith asked me to show some impact. So you're going to see a few little videos here, not a lot, a little bit about how we understand what we know about the Earth system and how we'll be able to track some of these things like the Sustainable Development Goals, like the changes over time, how we're able to know what's happening already. A few of the ideas and few examples of how we're doing something about them already, even though we should be taking other actions that are more long-term. There are some things that we can do now in a more adaptation mode, and I'm going to highlight a few of those. So again, what is NOAA doing here? We're the prediction people. We have the data, the science, the understanding of the Earth systems, and our job is to predict it and make those things useful to people to enhance society and societal interests. We have a Conservation and Management Authority. We have the fisheries. We're responsible for fisheries, some marine mammals. We're responsible for the Weather Service. How many of you actually knew that the Weather Service was a part of NOAA? Oh, good. I'm not sure they know that sometimes, but we're happy to have them anyway. And then we have an environmental stewardship mission. So it's very appropriate for us to be here working with you. We are not a public health agency, but working with you together, we can accomplish a whole lot. So we've got part of that equation. Title is One Health, and I know we're having a lot of discussions about what all these mean, and I'm not trying to get into a definitional thing, but when we started our program at NOAA, what we mean by One Health is that intersection of animal health, ecosystem health, and human health. But for us, you'll see the pictures here, the animal health for us is often marine animal health too. We're responsible for marine animals and fisheries. So what is the health of those, and how do they affect human health, and how are the changes we're making to our ecosystems affecting those? Same with the ecosystem. We do a lot about ecosystem management, services, and tracking. But for us, our mandate is also coastal, in that the United States includes the Great Lakes, so we manage the coast of the Great Lakes as well. That's our freshwater contribution. So some of this you don't really need to know, but I'm going to show you a little bit to set the context here. We all know the world is warming at a very rapid rate. I don't think that's a point of discussion at this point. It's well published, well documented. This data are stored in our National Centers for Environmental Information. We actually house a lot of the data for the world. We host data for the World Meteorological Organization and other countries, as well as our own, both domestic and global data sets. We know that the Arctic is rapidly warming more than any other part of the world. Let's see if this works now. It does. All right. So this is a video about sea ice, and what I want you to look at, this is about the age of sea ice. Some of you may have seen this before, but when you look at it, there you go. You're watching, it's from 1987, and you'll watch the white part is the older sea ice, the blue part is the lighter, it's the age of sea ice over years, and you'll see that it is changing over time. And if you look at it overlaid with the temperature of the planet, you can see, especially as we get into the 2000s, the age of the ice and the extent of the ice is changing dramatically. Now watch here. As the age goes down so rapidly, so quickly. And by the end of this, you'll see why we have so many concerns about our populations and our tribal populations in the Arctic, especially in Alaska for the United States. We're losing our sea ice at a rate more rapidly than we thought we would. That alone is problematic, as you know. The other piece is that our glaciers are melting much faster. That has more to do with our increased sea level rise, but look at the rapidity with which our glaciers are melting. That's the equivalent of chopping off 67 feet of all these glaciers and letting it just go right into the ocean. That changes in sea level rise are largely due to the glacier melting. It's not so much about the sea ice in the Arctic, because the sea ice is actually already taking up the space in the water. So glacial melt is a huge problem. Some of this is, as we said, irreversible. So we're talking about how we retain and how we can make changes in the Earth system so that we can at least do least damage as possible. We're really talking about how the oceans manage and retain heat. The real storage capacity is in our oceans, and this is the heat content of the oceans, which is also rising rapidly. So you're seeing this whole trend. You can see it's not rising rapidly equally everywhere. If you look at the map, the inset, you can see that in the middle of the ocean there's part that isn't quite as warm as some of the other parts. So it's not an even distribution, but overall the trend you can see is definitely rising. So combined You've all seen sea level rise, whether it's in Bangladesh, you've heard about it in Florida. If you look even in Alaska, around the world, we know we have a problem with many of our coastal cities, populations moving to coastal cities, and yet we're losing sea level at a rapid rate. In some cases, because of the changes in the ice caps, sea level is actually going up. So again, it's not a uniform answer everywhere, but the change is rapid. The change is more rapid than we as a society are able to deal with. So getting to what are we looking at in the next 20, 30, 40 years, without any changes in emissions, this is the scenario from the IPCC that says business as usual. Look at where the temperature change is going to be greatest. It's in the areas that are not currently used to dealing with temperature. Places that Seattle, I have a friend who lives in Seattle, lots of friends in Seattle. It's 90 degrees in Seattle. They are not used to it. They don't have air conditioning. Is that really the solution? I'm not so sure. But, you know, there are lots of places that are going to have to be dealing with extreme heat. And not just necessarily more heat, but they will be more frequent heat waves, more frequent extreme events. Normal day, just with heat alone, 15 days above the 15th percentile of what you're used to. What is normal now, what feels comfortable to you, isn't going to be comfortable for you anymore. You're going to have more days that seem abnormally hot. And that means a lot of things to different people. It's both physical response as well as the response to the ecosystem. It changes your habitat, it changes your vegetation, it changes your food supply, it changes how you actually interact with other people, when and how you go to the market, depending on what country you're in. It changes all kinds of things, not just, oh my gosh, it's hot, or I'm stuck in my apartment. So certainly most vulnerable populations will become more vulnerable. But these are the things that are going to affect all of us. So while you might think we're not going to feel it in the same way as some of the, you know, we're talking about inequality just a minute ago, we're all going to feel the changes in climate in some way, shape, or form. We've already seen increases in wildfires. We've already evidenced increased flooding, increased drought, prolonged drought in the U.S. alone. We're not impervious to this, so we may not feel it the same way because we have a greater buffer, we have the ability to respond more rapidly, but we will feel it, and we already are feeling it. Okay. One of the things that I think is going to be really valuable about the collaboration in our communities is this data issue. And I'm not going to spend a lot of time on it, but let me just tell you that people who do earth science, like data is a big thing. We have whole data committees and people spend their lives on data. And it's always been amazing to me that the public health equivalent is surveillance, and it's spotty. So this data mismatch is not there. I think one thing that the physical science and the biological sciences can do is help improve how how we manage and think about data. So I'm going to just do 2 slides and show you how we know what we know about the ocean and its changes and how it affects the climate system and other ecosystems. We have ships and buoys that go underneath the water, that sit on the top of the water. We've got tide gauges and stream gauges and all kinds of things that we use to actually monitor the system. And if you put them all together, that's what it looks like. So this could be a whole talk right there if I were a data person. They'd spend a day talking about all these things. But it's important for you to understand that part of the backbone upon which we're going to base our understanding about whether we are meeting the Sustainable Development Goals, whether we're improving our ecosystem, or whether we're just watching it go down, has to do with our observational networks. And those are not just about health, but they can be tooled, and the information from them can be used to build better products that inform and help us manage the health risks. So this is an underpinning for what you do. And my leadership will sometimes say, well, why are we working on health issues? Well, should CDC have to go build an observing system because we're not working on health issues? So we've definitely gotten over that. But I think the collaboration there and understanding the amount of time and money and effort that goes into building and maintaining these observing systems is huge on the earth science side of thing. And one of the big contributions I think we might be able to do better in using that information to help public health side and the environmental side. All right. Just as well. That was an animated one that didn't work. What it was showing you is basically all those data points in the ocean allow us to do things like predict an El Nino. And this slide right here, the animation would show the evolution of an El Nino. The red up at the top is the warmer waters. Thank you, in the back. The blue is the cooler waters moving in, sort of the opposite, La Nina. And this links the sea surface temperature with changes in vegetation. So look particularly over at the Horn of Africa. It's on both sides of the screen. And you see with an El Nino, you see a distinct change in the vegetation because the rainfall is greater during an El Nino event. So what this does is it allows us to use an El Nino forecast, what we understand about changes in rainfall and temperature, to predict changes in vegetation that affect things like infectious disease. Okay, next slide, please. There you go. So just one example here. This is not a Rift Valley fever lesson, but most of you probably are very well aware it's a mosquito-borne disease affecting livestock, humans, and can have huge economic consequences, particularly in East Africa. And this slide you see on the right is from a Rift Valley fever monitor. It's a product that NASA and the Department of Defense and USDA have been doing for quite a while. Based on an El Nino forecast, federal agencies get into this fragmentation thing. It shouldn't be a big deal that federal agencies put some information together and said, wow, there's an El Nino coming, and there's a greater risk of Rift Valley fever, but we're beginning to do that more systematically now. And using the monitor to say, all right, how do we actually do a better job of informing people and helping those who are in the response world think about it differently? Because we'd like to be able to get from this response and always surprised, whether it's heat waves or infectious disease. We shouldn't be surprised by the next Ebola or SARS. We understand enough about the Earth system that we shouldn't be surprised by these infectious disease outbreaks, certainly the ones that we know. So we're trying to use the environmental observations in a more systematic way to do things like this more regularly and help make sure that we're reaching the right audiences who are doing the disaster response, the donor community that's thinking ahead of time. All right, so this is going to be a bad year. Where do we want to be looking first? Where do we want to make sure we have vaccines pre-positioned or at least at the ready? What can we be doing ahead of time so that we are not responding behind the curve at every event? We've got a few examples of this. The one on the right is a malaria early warning system design. It's done by the International Research Institute for Climate and Society. It's a bit old now, but the basic principle is this. Take an El Nino forecast, do a little assessment of whether that's actually materializing, if you're going to have more rainfall. This is low cost. Then you add a little bit, okay, that's materializing, and you check to see if you have mosquitoes or increased outbreak of malaria, and you can do something ahead of time. Getting a lead time on this so it's not so responsive and not so costly to respond. You reduce the health impact, you reduce the economic burden, and you reduce the recovery costs. I mentioned sea surface temperatures. And I'm going to highlight this too because we've had a lot of focus on the Arctic in the news and the media, but what we haven't heard a lot about is changes in the sea surface temperature up there and what that's going to mean for our populations. And this is an example, but as our water is warm, we're going to see vibrios and things that cause cholera or shellfish poisoning and harmful algal blooms and probably contaminants. We don't know these things yet. They're going to be appearing in places where we're not used to seeing them. And so one of the types of vibrios, this particular one is from an outbreak of shellfish, but some vibrio species cause wound infections, and we're seeing more of those moving northward. So if you've got a wound infection and you're a fisherman, and your doctor isn't expecting that to be in your area, you could easily lose a limb if it's not diagnosed properly. Furthermore, we have other shellfish problems between the harmful algal blooms and the vibrios that affect the quality of the food, the ability of fishermen to harvest them, the food supply itself. So we're looking at, again, how are we going to feed our population when we're not sure of the quality of the food or where it's going to be or its availability. It's not just food, it's drinking water. I'm sure this is not news to you, but one of my favorite pictures is the guy holding the green glass. That is the drinking water. This is the Toledo example of a couple years ago where we had a problem with the harmful algal blooms in the Great Lakes. I know this is a meeting on global health. I'm trying to give a combination of examples because I want you to also understand we're not impervious to these things here. We have infrastructure and water infrastructure problems in the United States too. They're different than what you have in other countries. But we have a common threat here from changes in our ecosystem, and we're not managing well enough to be able to adapt or respond or avoid entirely. I just want to put this slide up here. We have had a rapidly emerging series of harmful algal blooms in the United States. Similar globally, the mapping capability for this is not strong, so we're actually setting about trying to put into a more global context the harmful algal blooms and the economic and human health impact. But look at that for the US alone. That's just in the last 5 years. And the last thing, I'd be remiss if I didn't mention drought and the fact that it's affecting everything that we're talking about here. It's food, it's health, it's animals directly. I had another slide I was going to use, but it was a little too sad to start the morning with. I also had a slide of a seal being exposed to domoic acid in the marine environment. Seals go into seizure because the domoic acid from a harmful algal bloom affects their brain. Similarly, this impacts on animals. If you care about the animals themselves, it's a problem. If you care about the animals as a food supply, it's a problem. So we have this multiplicity of effects, this combination of things, whether it's heat exacerbates drought, exacerbates the flooding that comes from the rains that are welcome, but if they come in the wrong time or if they come too quickly, then you have a different set of problems. So we're really stressing ourselves and our environment in a way that we have to do a better job of that, as you say, in the next 20 years. This is California. Probably you've seen some of these in the news. Look at the difference, 2011 to 2015, just 4 years apart. This is the impact of the drought in California. Now, it's a different type of impact, it's a water quality, but it is a combination of how we manage the water in the United States, where it comes from, and the fact that we have had so little snowpack and so little rainfall for such a long time. These are pretty dramatic effects. And the last thing, given in the whole One Health context here, I wanted to come back to the marine animal side of things. The middle picture is a sea lion that was getting an MRI in San Francisco General at midnight when it wasn't totally open to everybody else. But that's how we learned how damaging the domoic acid is to the human brain as well. So whether you care about the animals themselves, whether you care about the ecosystem, whether you care about them as sentinels for human health, what we're doing to our ecosystem has effect on all three. And I know that everybody in this audience is already committed to doing something about helping change that or make sure we don't do as much damage as we could in the future. And I just think it's important to understand that there's a marine component to this too, both in the quality of the waters and the quality of the waters for human, whether it's recreation or food supply, and for the animals themselves, the inherent value of nature. So, my last slide here, getting back to how do we behave, how our institutions function differently in the future, and the fact that I'm actually standing here before you with the opportunity to engage with you. I would like to hope that when we leave here, that when you leave here, you think about working with your oceanographer, your biologist, your climate person, your meteorologist a little bit differently than you did before. You might have known it's there, but not done anything about it. We can chart this path together, and I think we have an opportunity to really work differently and show our children that maybe we didn't actually save the world yet, but we are working differently. We are at a moment in time where our institutional context and our institutional constructs need to change, and how we work together. I mean, you're all in universities, or most of you in universities. You're at the forefront of training students and people how to think differently, how to behave differently. How important it is when you're writing that grant to go down the hall to the other building and find the climate person and put them on the proposal and talk to them and go figure out who they are. I mean, you can do an awful lot from a university setting because you are at the very front end of the next generation of people who are going to actually make these changes if we can't do it, or deal with them if we can. So I will stop with that and say thank you very much. There are lots of opportunities for collaboration, and I hope that we start a new path here today. Thank you.
morning, everyone. First, I'm very grateful to Keith and the CUJH meeting organizers for the opportunity to join you and this very esteemed panel to help highlight this year's theme, Healthy People, Healthy Ecosystems. My name is Montira Ponsiri. I'm from Cornell University, where I work with the Planetary Health Alliance, which is a consortium of universities, NGOs, and other institutions collaborating on planetary health by engaging in research, education, and science policy. I had the great privilege of working with Richard Hurton and other luminaries on the Rockefeller Foundation Lancet Commission on Planetary Health. What the commission did was to assess the scale of the risk to human health posed by multiple concurrent global environmental changes which we, humanity, are driving. The commission made the case that we need to address global health and global health practice differently in a way that integrates an understanding of how our underpinning Earth systems influence the broader determinants of health. The report's key message, the Commission report's key message, was that while we made significant gains in health and development over the last 50 years, those gains are likely to be reversed by the unprecedented global environmental changes that we're now experiencing. But importantly, these losses can be reversed, or these losses can be mitigated or minimized if we understand the drivers and consequences of these global environmental changes, and that this understanding is reflected in our policy and planning. So what I'm going to be doing in this talk is to share some findings from the Commission report's assessment. And then I'll discuss some science-based policy strategies that can be used to address health together with environmental sustainability and development. And then I'll end with some thoughts on how the multidisciplinary approach which planetary health represents can inform how we design research, conduct research, and apply that research to solve complex planetary health challenges. When the Commission started its work, we were faced with a paradox, which you'll see in this slide and the next. Population has increased. The share of our global population living in extreme poverty has dramatically declined to less than 10% as of last year. Life expectancy has increased. At the same time, our exploitation of natural resources has been demonstrated widely. Our energy use, our water use have dramatically increased. Percent of the total land used for agriculture has increased but leveled off because we've exploited most of our available land for food and sometimes for energy provision. So we made remarkable gains in human well-being over the last 50 years. But again, we face this exploitation of our natural resources in achieving the gains that we've made. We've deforested in the tropics. We've acidified our oceans. We've experienced unparalleled changes in temperature, accompanied by increases in greenhouse gases, many at levels which haven't been experienced in some 800,000 years. We've lost biodiversity at least 100 times the background rate. These are dramatic changes. Why do they matter? We know that the ecosystem services literature shows that we benefit indirectly and directly from healthy natural systems like oceans, rivers, wetlands, and forests. These benefits include the provision of our food, fuel, fiber, the regulation of our air, our climate, filtration of our water. The WHO recognizes that healthy natural systems are the platform for good health. So the unprecedented global environmental changes we're experiencing threaten to reverse our course of improving global health. They threaten our sustainable development. In short, we've mortgaged our future to attain our health and development. This is the premise of planetary health. Planetary health is the health of human civilization and the state of the natural systems on which we depend. Planetary health says that we have to pay attention to the condition of the natural systems on which human health depends. And unless we dramatically change the way that we currently live and prosper, we risk the health of human civilization. Let me give you a few examples of the types of environmental change human health relationships that fall under the planetary health framework. This is not exhaustive. Some of the effects are direct. For example, climate change leads to extremes in temperature and higher temperatures, which can cause heat stress and temperature-related illness and death. Some effects are ecosystem mediated. For example, increasing concentrations of atmospheric CO2 can lead to significant reductions in the amount of zinc, iron, and protein in important grain crops like rice and wheat. This has important implications for our nutritional security. There are other ecosystem-mediated effects that are particularly relevant to this part of the country. The risk of vector-borne diseases like Lyme disease. Forest loss and land cover change can lead to changes in the composition of the community of animals which act as reservoir hosts of the Lyme disease bacterium, which affect the transmission risk of Lyme disease to people. And then there are the indirect effects of global environmental changes, like coral reef destruction and urbanization processes. These relationships are more difficult to characterize and to quantify, but over the long term, may be among the most important. What hasn't been well studied, which concerns us and the Commission and the larger community, is that these multiple environmental changes are interacting together to affect human health. These are the many environmental factors affecting food quality and food availability. We need to better understand how these factors work in concert. Most studies focus on one driver of environmental change. The concern is for the potential negative and synergistic interactions. Another issue that the Commission raised is that environmental change can increase inequities. This is a graph from a 2013 paper by Myers and colleagues. It illustrates the idea of an ecological transition, where populations replace their natural infrastructure, which had provided fundamental services like the provision of food, safe drinking water, with markets and engineered infrastructure. This transition is associated with health benefits for most people who were able to make this transition successfully. But poor populations, whose natural systems are degraded, are increasingly at risk because their poverty prevents them from accessing the benefits of markets and engineered infrastructure. So most of the burdens associated with increasingly degraded natural systems will be borne by the poor and by future generations. So I've described some of the problems. I'd like to now turn to the use of science-based, proven strategies to address environmental sustainability together with human health and developing in the context of cities. In a commentary in the first issue of the Planetary Health Journal released this week, thank you, Richard, and his team for that wonderful introduction and forum. In a commentary, Tony Caipan describes cities as the dominant human habitat. By 2030, most of our world's population will live in cities. 95% of global population growth will occur in cities in low and middle-income countries. Cities consist of complex socio-environmental and economic interactions and feedbacks, which can lead to positive and negative human health outcomes. Cities can be redesigned or designed with people in mind to improve unhealthy conditions. Jonathan Patz is here. He's one of the leading thinkers on this issue. Healthy city design features density, features mixed uses, green spaces, pedestrian and good transit infrastructure. The multiple health benefits of these features of healthy city design have been well documented. Lower risk of car accidents, improved air pollution, and the lower attendant risk of cardiovascular and respiratory diseases. Green spaces, which promote physical activity, which promote social interaction, and reduce the urban heat island effect. In practice, we have tools like the health impact assessment, which when used during the policy planning process as part of development projects, can help identify and maximize human health benefits and can identify and minimize adverse human health impacts. For example, the US EPA worked with the city of Proctor Creek, Georgia, to apply HIA to a green street design, which was initially targeted to reduce flooding and stormwater runoff. The use of HIA led CD decision makers to increase the scale of their Green Street design by threefold to capture the human health benefits of walkability, public safety, and reduce urban heat island effect. At a time when resources are limited, what we do has to meet multiple objectives. And so addressing interlinked environmental change and human health risks makes even more sense to do. And we can share lessons learned from these kinds of case studies with other places that are experiencing or anticipating similar environmental health risks. So I'd like to close with some thoughts on how we can move forward together as a community to address urgent planetary health challenges. Planetary health represents, as we heard, a multidisciplinary approach to address interlinked environmental human health challenges by focusing on prevention, that is, looking upstream at how and why human activity drives environmental changes, which lead to adverse human health outcomes. This is an opportunity, as you've heard, for new strategic partnerships, not only across academic disciplines, but also to include those ultimate users of scientific findings as part of the research process, where you begin that research design with a known policy need for science, and you end by having a stronger science base, which policymakers and civil society can use to make the case to governments to address human health and natural systems together to address complex planetary health changes. We can build on tools, existing tools like health impact assessments and environmental impact assessments to take into account an understanding of the relationships between environmental condition and human health. This can give decision makers a bigger picture understanding of the interconnections between environmental condition and human health. And that understanding can encourage a more systems-based approach to assessing, to anticipating, monitoring, and managing complex planetary health challenges.
Excuse me, good morning. I too would like to add my thanks to Keith Martin and the organizers for the invitation to join you here this morning. Wait for a moment for the slides to come up. Are they coming? I know. My name is Andy McCabe. I'm the Chief Executive Officer of the Association of American Veterinary Medical Colleges, and I'm pleased to give Cesar Victoria's talk. Oh, wait. Actually, no, I'm not ready to give that talk. Unless you'd like to give mine, Cesar. It'll be coming up in a moment, I'm sure. Mine's the one with the orange color on the opening slide, and it'll be coming up here in a moment. There we are. Thank you very much. So, the theme of the conference here is healthy people and healthy ecosystems. And I'm quite certain that the reason that I was invited to address you today and talk about this is to fill in the missing piece, healthy animals. So, I'm going to focus my comments today on livestock and animal agriculture. And I suppose if I were to ask this audience today, is livestock part of the problem or part of the solution to preserving planetary health, we would align ourselves on different sides of the auditorium. But as I learned in law school, the answer to this question, like most questions, any good lawyer would tell you is, it depends. And as I learned after law school, a less than good lawyer would tell you it depends on what you want the answer to be. So with that, let's move into what do we mean by healthy animals? It's the foundation for global food security because healthy animals lead to sustainable production of animal-sourced foods, which leads to food and nutritional security. Livestock health is foundational to both global food security and poverty reduction. And here's how that works. On the global food security issue, good livestock health results in reduction of endemic animal diseases, leading to improved animal husbandry and increased productivity. On poverty reduction, Animal agriculture, unlike other forms of agriculture, can lead to income generation. And if we eradicate transboundary animal diseases and gain access to international markets, it can profoundly alter the economy of the developing world. Here's an example of increasing animal productivity. On the left side, we have the potential productivity for livestock. And on the following bar graphs there, we have the contribution of various elements. The far right shows about where we are. This is just a notional example. So the realized productivity might only be 1/4 or 1/3 of what's potentially there. There are losses due to poor husbandry, losses due to poor nutrition, losses due to morbidity and mortality, and most notably, losses due to unrealized genetic potential. Let's turn now to the interface between animals and humans. And we see that the most emerging diseases are zoonotic in nature, that is, they have an animal reservoir. 60% of all infectious diseases of humans are zoonotic, 75% of emerging diseases, and 80% of biothreat agents of concern are zoonotic in nature. And there's a lot of reason for seeing the increase in zoonotic diseases across the world. But at least one part of that is due to increased incursion on wildlife habitat as a result of farming and looking for bushmeat. But there's a positive side to the interface between human and animals as well. And that is, we notice that there's a high incidence of stunting among children under 5 throughout much of the developing world, approaching over 40% in much of sub-Saharan Africa and India. Animal source protein is an essential part of the solution to this problem. So for instance, dairy, meat, and eggs can provide essential nutrients in a high quality fashion and very compact fashion that purely plant-based food cannot. And finally, let's turn to the interface between animals and the environment. And here I think the greatest opportunity is the unique role that ruminants fill in terms of turning forage land into meat and fiber that can be used by humans, especially in areas that cannot be cultivated for crops. So here's the deal. The demand for livestock commodities in the developing world is going to increase, and it will be met. The question is how. And I want to turn the rest of my talk to these various scenarios. Scenario 1 is importing livestock products from the developed world. Scenario 2 is importing industrial or livestock industrial production know-how. And the third scenario is transforming smallholder livestock systems. So let's turn to scenario 1. What about importing livestock products from the developed world? Well, it doesn't come without its own risks. We know that westernized systems of animal production in highly intensified systems, concentrated animal feeding systems, has its own problems, resulting in climate change and contributing to antimicrobial resistance and environmental degradation. But this same intensification has produced a great deal of benefit. So for instance, in crop production, GPS-enabled planting and plowing can result in the precise application of nutrients to different parts of fields, which has greatly increased production. Here's an example that shows some of the benefits of these improvements in agriculture. So based on current production methods, we are saving about 34% in production of beef cattle and about 76% in production of milk cows as compared to 1950s technology. So we can create some significant advantages by adapting and using the technology. Let's look at scenario number 2, importing technological know-how to the developing world to see if that can help improve things. Here's an example related specifically to eggs. It shows that eggs, again, are a great source of protein and can contribute to maternal and child health improvement. But if by 2050, as the global population surpasses 9 billion people, there will be about a 60% increase in the demand for meat, milk, and eggs. And that would come up to 1.9 trillion eggs by the year 2050. So if we look at today, there are about 6.5 billion laying hens in the world today, each one producing about 184 eggs a year. If we want to meet that deficit by 2050, we would nearly need to double the number of hens. Or we can look at just one more egg per hen per year would help meet the demand and require 4 billion fewer hens. So there are opportunities to increase production without increasing the footprint or the number of animals. And indeed, there's some studies that indicate that with proper tools and investment throughout Africa, we could nearly quadruple production within the next 20 years. And finally, let's look at scenario number 3, which is transforming smallholder livestock systems. And I think it almost goes without saying that smallholders are part of the solution. And it's not based on sentimentality, as this slide indicates, but it's based on good evidence of what the contribution is from many different smallholder producers. 70% of the world's rural poor relies on livestock. And of the more than 600 million poor livestock keepers in the world, about 2/3 are rural women, and I'll have more to say on that in a moment. There's a lot of intangible benefits to owning livestock, including investment, insurance, and other ways. As many people will refer to their livestock as their bank account. Livestock manure can help restore degraded land, and much of the markets in the developing world are highly localized. So who benefits from increased livestock health and food security? Clearly the poor, smallholders, and women. And how do they benefit? By increasing income, improved quality nutrition, and capital accumulation. This is an example of one notable non-governmental organization, Heifer International, recognizing the value of empowering women and developing social capital at achieving the Sustainable Development Goals. Another specific example is Rabbits for Resilience, another NGO designed to help improve smallholder livestock production. And why rabbits? Well, they reproduce like rabbits. And they're pretty efficient. It's a pretty efficient conversion of food energy into feed energy, and they can utilize foods that people cannot. Another one from the same developer is Pigs for Peace. And again, a lot of this has to do with the fecundity of pigs, that you can get 6 to 12 piglets at each litter, and at least 2 litters per year. So you can get a great deal of growth. And again, it's the value add of livestock to the chain of development. So we've touched on some of the Sustainable Development Goals. This talk I kind of focused on these specific ones that are aimed at improving child and maternal health through increased high-quality animal protein, eradicating poverty by adding value to raw agricultural products, and most importantly, empowering women and girls, many of whom tend to be the livestock tenders and can benefit directly from the economic value that's added. So, what's the point of all of this? What's the answer to the question? Is livestock part of the problem or part of the solution? The answer is clearly yes. The point is that the problems of animals, humans, and the environment are inextricably linked, and it will require a holistic, integrated approach to solve these complex problems. And especially appropriate livestock interventions are an essential part of solving this problem. They can empower women and girls, they can strengthen civil institutions, they can create economic opportunity, and reduce pressure on habitat. This slide represents in the bottom right the interface between cultivated land and virgin forest. Up at the top right, you can see this is where the mountain gorillas live. And many times in the veterinary colleges today, we get very altruistic young people who want to come and work to save the mountain gorilla. And they all want to work in that dense forest to understand those animals and work to preserve their habitat. And I think increasingly the answer is clear that they need to be working on the left side of that line. And over on the right, you can see subsistence farmers that are working to cultivate soil that's been clear-cut, pretty marginal quality soil. They may only get 2 or 3 years of production out of that land and result in having to go further inland. But what if we were to use livestock in a sustainable way to preserve that habitat and prevent the incursion and therefore contribute to planetary health? Thank you.
Well, that was really superb. We only have about 10 minutes, so I'm going to ask, I really apologize for that before we go into the next speaker. So if one person could go up to each mic, we'll take one question, we'll pool them all, and we'll rapidly go through them so we can be on time for the next talk. So we were going to have a discussion, but we have to change, obviously. So we'll go from this side across. Yes, ma'am.
Hi there. My name's Noelle Sullivan. I'm at Northwestern University in the Global Health Studies program. I really wanted to thank everyone for doing such a comprehensive job of looking at planetary health. And to just be brief, because I know there's very little time. I'm a bit curious about the way that, considering many of us are working in this field, the way that medicine actually contributes to some of the planetary health problems. So a month ago, there was a big report that came out about hospital waste and how we're throwing away all of this completely unused products. And I think it would be really interesting to hear some commentary about how we're implicated in some sense, at least in the way that we practice medicine, in the very problems that then medicine and all of the other integrated portions of that are trying to solve.
Great, thank you. We'll go into the center and then over there. Yes, sir.
Yeah, Jim Shelton, Global Health Science and Practice Journal, Johns Hopkins University. I guess for Dr. McCabe, with respect to the ruminants particularly, one hears about methane gas as being a significant contributor to global warming, and actually pound for pound worse than CO2. So I'm wondering, how significant, maybe somebody else can answer this question, how significant methane gas from, especially from the ruminants, is to global climate change. And of course, recognizing that beef is not necessarily the healthiest thing for people to eat, at least in large quantities either.
Thank you, Jim. And yes, ma'am.
Erica Frank, past president of Physicians for Social Responsibility and chair of the Educational Products Subcommittee for CUG. And I just wanted to ask the panelists and also folks in the audience, we're collecting materials on climate change and health for CUG and for the Educational Products Subcommittee. So if the panelists could recommend resources that would be of interest, or if folks in the audience have resources of interest. Also, for those who'd like, there is already a 1-month climate change and health course that's free and accredited. If people want to learn more about this, that's available through nextgenu.org. Thanks.
Thank you, Erica. So we'll start on this side from Andy, and then we'll work this way.
Thank you. So I'm going to not answer the first and third question. I'm going to go straight to the second one since it was directed at me. There is no question that ruminants contribute to greenhouse gases by their belching of methane, the eructation. So it's a significant contributor. I confess I don't know the exact amount, but I don't think that's really the issue here. But I think and then your other question was about, perhaps I would define it as the difference between a Western diet that's heavy in grain-fattened beef and its contributions to some of the non-infectious disease problems we're seeing with obesity and heart disease. But I think we need to divide those two things up in different ways. As I said, is animal production part of the problem or part of the solution? And the answer is yes. In highly concentrated feeding operations, such as those seen in the United States, where you get large concentrations of beef cattle consuming high concentrate feeds, meaning corn and soybeans, to be fattened, yes, that's a significant contributor. But what about the role of grass-fed beef or small ruminants, again, in using marginal quality soil that can't be used for other purposes, that is not amenable to crop production, does not get rain? And I think there you can see quite a different aspect of things. But I can't leave that alone without saying, again, on the developed world side, that there is the opportunity for a number of technological solutions to help address some of these problems. And so, for instance, if we had a very diffused animal production system in the United States, it would be very difficult to address these problems. The very aspect of intensification allows us to apply technological solutions in a way that we couldn't otherwise. So, for instance, imagine a dairy facility with lots of cows, but in an enclosed location or semi-enclosed location where they could harvest or capture some of that methane. Then it could be used for other purposes and not contribute to greenhouse gas. So I think it's clearly two sides of the question, and it's a continuum. It's not an either-or thing.
Go ahead, Montero. Thanks.
So I'll try to address the first question on the role of the medical community. I think the strategy of improving health through better stewardship of our natural systems is a new concept in medical practice and in global health practice. When we started engaging with government ministers, mostly in environment, but also in health, on planetary health and how planetary health science could be used to inform policy and best management practices and improve the work that they do in the field, suggested to us that medical service workers who do outreach in the field to deliver health care could help to do outreach on planetary health, specifically on the critical relationships between environmental changes and environmental condition and human health, to incentivize behavioral change at the individual and the community level, because actions at multiple levels will be required to begin to affect the kinds of changes that we've been talking about.
Thanks for the question about hospital waste. Those of you who know the United Kingdom will know the name of somebody called David Pension. David leads the sustainability unit of the National Health Service. One advantage of a single-payer system with a National Health Service is that it's still broadly coordinated, a little fragmented nowadays, but still broadly coordinated, so there can be a national plan for sustainability to try and address the issues of waste in the system, as you rightly identify. It's a very important dimension of the sustainability agenda, but I also want to throw in here the question of research waste. A different dimension of waste, but still very important. As much as 85%, this is work that we've published from Ian Chalmers and Paul Glasio, as much as 85% of research investment is wasted. It's wasted because we don't ask the right questions. It's wasted because we choose the wrong methods. It's wasted because regulations get in the way. It's wasted because we report the results in a biased fashion, or it's wasted because it's inaccessible. And so when we're thinking about research dollars, and we're thinking about using our research to maximum social effect, we could do a better job ourselves in this hall. Just on Jim's point, I just want to pick up the issue of farmers should be our friends. They should. I completely agree with that. But it's a struggle. So when we launched a series on climate change and health a few years ago, we had a great launch. One of the papers made a recommendation about just rethinking the amount of meat you should eat. And the recommendation was that your portion of meat per day should be no more than 80 grams, which was a reduction. Well, my God, all hell broke loose. The National Farmers Union went into overdrive. They called us, we want to destroy the entire agricultural industry of the United Kingdom. We hated farmers, we hated animals, we were mad, hippie, vegetarian-loving, left-wingers. I mean, it was crazy. And this was a scientific review in a boring old medical journal explaining why actually probably the evidence said that you should definitely eat meat, but try and keep it to 80 grams. I mean, these people are crazy. So, you know, farmers, I love them, but please, you know, it's a two-way shop here. So I'm willing to stick to my meat. I'm happy to have it, but, you know, they need to back off a little bit and read some evidence. So farmers, but farmers in their place.
Thank you, Richard. Truly.
You're putting me after him every time. It's not fair. So I actually have a couple of really direct answers. I'm going to pick up on the hospital one. There is in the U.S. An effort to improve the resilience of hospitals, which improves waste and that sort of thing. It's called the Sustainable Scruffy. Hospitals for Sustainable Resilience, and I'm going to answer the question about education and tell you where to find this. But it is an effort led by hospitals and some insurance industry leaders to make hospitals more green and sustainable. And I actually, if Montira hadn't said it, I was going to. I think that the other opportunity, huge opportunity, is you are the trusted resource for people, and whether you're actually a medical doctor or educator, or you're working in a healthcare facility, or you're in the field in a response mode, you are a trusted resource, and you have an opportunity, and I would argue perhaps even an obligation in this day and age, to begin to educate your patient, your citizenry, the people you serve. And I'm thrilled that I heard yesterday in the research section on Sustainable Development Goals that there is an effort underway to develop a curriculum for climate and health in universities. And coming from the climate program in NOAA, which, yes, has a big bullseye on it, has a huge education component. We have an education office, and there are resources. If you see me after, I can point you specifically, but if you were to just Google climatetoolkit.gov or climate.gov, you'll find the toolkits, and there's a lot of curriculum for different levels. Now, I'm not sure that we've done a really good job of graduate level curriculum, though. There's K-12 for sure, but graduate curriculum, I'm not so sure. It's a little bit not as comprehensive, so I think maybe that's a place for work.
Thank you very much, Julian. Do look at the NOAA website, because it really is, like the EPA website, is truly spectacular. Well, you have all been absolutely fantastic. Julie, Richard, Montira, and Andrew. Please give everybody a big hand. Thank you. Really awesome. Thanks so much.